Hello everyone, today in this video we'll be discussing the second module of CN, which is error and flow control. Here we are covering three topics, very easy topics and very important questions from exam point of view we'll be discussing. Make sure you watch this video till the end, and if you watch this video till the end you can easily score more than 80% marks. And make sure you hit the like button, subscribe to my channel for more videos like this. Without wasting any more time, let's get started. So the first topic is data link layer. Okay, the layers which we had discussed in the module 1. The second layer is the data link layer. Here we'll be having error detection and correction. So why do we need error correction and detection? See, we when we send the data from one point to another point, okay, from one point to another point, when we send the data, what happens is there can be some errors in between. There can be interference between by the hackers, so the data can be changed. So we have to detect what data has been changed, and we have to correct that data. Okay, so whenever you transfer data, it can be hacked or changed. The change or the error can be of two types. Okay, what are the two types of error? First is a single bit error. Second is the burst error. Single bit, by the name itself you can understand there is a single bit getting changed here. Burst means more bits are getting changed at the same time. Okay, so these are two types of errors, and the concept of detecting or correcting errors is called as redundancy. And to implement redundancy, we can do it using various schemes. We will be learning about the block coding now. Okay, so what is block coding? Suppose we have a k bit word. Okay, k bit means 101. Suppose we have our redundant bits are added and the n bit is formed. So if it is 101, we'll be adding another two bits, so it will be 1110. Okay, like that. So this is the redundant bits which are added. So that is called as the n word. The whole bit formed is called as n bit word, and that is a code word. Okay, it is also called as a code word. And k plus r is equal to n. Okay, first k bits are there, when we are adding r bits, so it will be total of n bits. Okay, so let's have a look at the visualization. So here is the sender, here is the receiver. From the sender, it is the encoding. We will be encoding the k bits data word into a generator, and that will generate a n bits code word that will be unreliably transmitted to the receiver's end, and the n bits will be received here. And the checker will discard the r bits and just extract the first k bits, and that will be the decoding. So the k bits are received here, and k bits were sent from here. So if there is any change in the data, the k bits which we get will be different. Okay, so that will be known as it is not right one, it is corrupted data. So here we'll be using a Hamming distance. What is a Hamming distance? It is a number of differences in the bits of two words. So Hamming distance is of suppose these two will be equal to 2. Why? Because here two ones are there, here two zeros are there, those are not equal, so the Hamming distance is 2. Parity checking code is mostly used for the detecting errors. What is parity checking code? Parity checking code will be sending the words from here A3, A2, A0, A1. Okay, 4-bit word we are sending, and that is going to a generator, and it will be generating a parity bit here, R0. So the code word will be A3, A2, A1, and R0. Now this word will be sent here, and this will be received here, and then it will be gone to the checker, and it will check the S0. Means it will calculate the S0, and based on the S0 we'll be doing the decision if it is to be discarded or we have to take it. Okay, so what is the S0? Let's have a look. So how do we generate R0? R0 is generated by A3 plus A2 plus A1 plus A0 modulo 2. When we do this, we'll be generating R0, which will be putting here, and there will be some mechanism in the checker in which it will be able to do the modulo 2's reverse, and it will get back all of these, and it will be checking if it is same or not. Based on that, it will be receiving or not receiving. Okay, so need not go into the depth. Whatever is needed to be going into the depth, I will be going there. Okay, from the exam point of view. Next is the cyclic code. This is very important question from exam point of view. Okay, what is cyclic codes? We add the bits and the add by doing division operation. Okay, let's take an example. Here is the encoder. Okay, this is the data word 1001. I have to transfer from one point to another point, but we have to do the cyclic codes also. CRC, cyclic codes is cyclic redundancy check also. Okay, CRC. So encoding, how do? We do the division operation here. Okay, we'll be always dividing with 1011. Okay, this is a standard one, and 1001 will be taking here 1001, and then we'll be dividing it. How we'll be dividing, I'll be discussing in detail after some time with the actual question from exam paper. We'll be adding some zeros here and doing the division operation. We'll get a remainder. That remainder we'll be adding along with 1001. The data word will be adding a remainder, so this becomes the code word, and this will be passed. Okay, and the decoder side also the same thing happens. The code word will be taken here and divided, and if the remainder is 0, that means the data word is accepted. If the remainder is not 0, it is not accepted. Okay, why? Because if this is corrupted, means the remainder will not be equivalent of the data word here, right? It will again give a reminder. If it is not corrupted, means the remainder will be added to here, and it will be completely divisible, right? You got my point. So let's have a look at the exam question. Very important. So let's have a look at it quickly. We change the pointer to the pen. Okay, so the first step, what you have to do, observe here carefully. Given the data word, this one. This is the k. Okay, this is of k bits, and the divisor is this one, 100 10111. Show the generation of CSC code word at the center set using binary division. Okay, so first what you have to do, you have to write the divisor here, 10111. Okay, and you have to use this k word here, 101001111. Okay, after you have written this one, all you have to do is check the first here. It is 1 and it is 1. So 1 multiplied by 1. After multiplying by 1, put this same value here. Okay, put this same value here. When you put this same value here, you'll be getting 10111. Okay, then subtract it. After you subtract it, if there is a difference, see, the first is 0 here, this is 1 here. There is a difference, so difference will be 1. Again, there is a difference here, so it will be 1. And this will be 0. And this is also same, it is 0. We have to do only first 4. Okay, we have to not do the 5. After you have done this much, then take this one here. Now check the first bit. It is 0 multiplied by 0. If you multiply by 0, you'll be getting 00000. Subtract it, same answer will be getting, but not consider the first one, 0111. Okay, then take this one here. After you take this one, check the first bit. Again 0, multiply by 0 here, and again it will be 00000. Okay, subtract it, you will be getting the same thing, 1111. Okay, again take this one here. Okay, now since there is 1 here, we'll be multiplying it with 1, so it will be 10111. Okay, 10111. Now subtract it again, we'll be getting here 1000. Again from here we'll be taking the 1 here, and since it is again 1 here, we'll be again multiplying with 1 here. Okay, and we'll be putting here 10111. Then subtract it again, so what we'll be getting here, 0110. Okay, 0110 is what we have got. Okay, so this is the thing we have to replace in the top. Okay, but before that we also have to take 4 zeros here. Okay, after you have done this much, then at this point just make a marking here. Okay, like you have to get to know, like this is the point where you had stopped. Okay, after that you will be taking here, this is not the final answer. Okay, you have to take here and mark it as like this. Okay, 0110. Now from here you will be taking 4 zeros. How do we get to know that how many zeros has to be taken? The number of this one, this is 5 here, 5 bits are here. So 5 minus 1, that many bits you have to put as zeros. Okay, so 4 bits as zeros you have to put here. Okay, that is how you decide. So 4 zeros I'll put, 1 2 3 4. So 4 times you have to take 0. Okay, I'll be just doing it directly now. So here 0110 is there, I'll be taking 0. Since the first bit is 0, then I have to multiply it with 0. So I'll be taking 00000, subtracting it. So this is the first 0. Okay, I'll be writing a 1 here. Don't get confused. 1100. Right. So again the 0 will be taken from the top. This is the second 0, and here since 1 is there, I'll be writing 10111. Again we'll be subtracting 1111. Okay, I'll be taking the third 0 here from the top. Okay, quotient I'm not writing because it doesn't matter. We are not concerned about the question. We just want the remainder. That's the final answer. Again, it is 1, so it is 10111, and we'll be subtracting, and this will be 1001. Again, the fourth 0 will be taking here. Fourth 0. Again, it is 1, so 10111. Again, we'll be subtracting. So what we get here, subtraction 0101. Okay. So this is the 4 bits we have to use. This is a remainder. Along with the code word, we have to add these 4 words. Okay, 0101. Okay, so what we will do, the code word with the k words which was given is, k word is equal to 101001111. Right, after that you have to add the r bits here, which is 0101. So this becomes the code word. Okay, code word which is of n bits. This is your final answer. Okay, so I hope so you have got to know. Let's move on to the next topic, which is polynomials. So a better way to store the binary values is by using polynomials. So let me change the pointer. Okay, so better way to store the binary values is using polynomials. What is polynomials? See, x square plus 2x plus 1, this is polynomials. Okay, here we'll be having a coefficient, this is coefficient, then this is the variable, and what value it has, like x square is equal to 2 is the exponent here, x cube 3 is the exponent here. Okay, like that, that is the polynomials. And to represent the polynomials we'll be using like this. Okay, to represent the polynomials, suppose that we have to represent 1x square plus 0x5 plus 0x4, like that. Okay, first we'll be starting from here. Suppose that I want to represent 1000011. Okay, this thing I have to represent using polynomials. What I'll be doing, 1 will be taken here as a coefficient, and the power here, like if you count from here, it will be 6, 0 to 6, you will be taking that exponent here. Okay, that will be taken as the exponent, so it will be 1 power 6. Suppose that I want to do for this one, this is 2 and this is 0, so it will be 0 into 2, sorry, not 0 into 2, it will be 0x square, like that. Okay, you have to do for this one, it is 0 here and this is 1 here, so 1x power 0, like that. Okay, you got to know. So what happens here is the zeros term will not consider. If we simplify this equation here, we'll be getting x power 6 plus x plus 1. It will be only 3 terms to store this whole value. To store 6 or 7 bits value, we are just using 3 terms. So isn't it short? So this is why the polynomials is used. It is easier to store in a short form. Okay, and doing the same thing using the polynomials, the cyclic code, the same thing whatever I discussed with bits, same thing will pass here. Data will be passed here, divisor will be here, will be multiplying and getting the remainder that will be augmented with the data word. Okay, advantages are what? Very good performance and detects the single bit errors, double bit errors, odd errors and burst errors. Okay, and can be easily implemented using software and hardware. Next, we have the checksum. Very, very important question. Okay, what is checksum? Checksum is determining technique that can be applied to any message. So here what happens? This is the sender side, this is the receiver side. Okay, and this is the message which is divided into m bits. Okay, after that this will be passed to a generator here, and generator will again generate another m bits. Okay, and this m bits will be concatenated with this m bits, and this will be passed here to the checker. And checker will take these two values here, and it will be taken here, and that will be checked if it is all zeros. If this answer which checker has generated, if it is all zeros, then the answer is correct, the code word is not corrupted. If it is not zeros, then means the code word is corrupted, it will be not taken, it will be discarded. Okay, let's discuss this with an example. Okay, so suppose that I want to pass the data 7, 5, 12, 6 and 6. Okay, suppose that I want to pass this data, what I will do, these are the m bits. Now I have to generate another m bit here. This one I have to generate. How do I generate? I'll add up all of this. If I add up all of this, I'll be getting 36. Okay, so 36 will be put here, 36. Okay, and this whole thing will be passed to the receiver side. In receiver side also the same thing will happen. It will first do the calculation and generate this value here. It will generate 7, 5, 12, 6, 6, and after calculating, it will generate 36. Note that if it was any of the values had been changed here during the transmission, it will not get the 36 value. Now we will do the XOR operation here. XOR means if it is same, the XOR of them will be 0. 7 XOR 7 is 0, 5 XOR 5 is 0, and so on. So all of them, if they are same, it is 0. If any one of the bit has changed, this will not give us 0 because it is changed here, and this will also not give us 0 because it is changed, because the whole sum will be changed if any of the bits will be changed, right? So then again the answer will not be 0, so we'll get to know that the something is changed here. Okay, that's how we use the checksum. Moving on to the second topic from the 3 topics which I had mentioned, the second topic is the DLC, which is the data link control. Okay, so let's have a look at what it has. The data link control has the DLC services, and we need to understand 3 concepts. Okay, the first one is the framing. The framing means what? Suppose that you have a photo and you will be putting a frame on top of that. That is called as framing. Means you are putting the borders and the boundary on it, right? So that is only called as framing. Why we use framing here? Suppose that we want to transfer n number of bits. Okay, and those are different words. This is one word, this is one word. How we will get to know if there is a space in between? We cannot pass space here, so we use a special character or a special flag means a special set of digits. Like suppose that 11101 is designated as a separator, so whenever we pass a value, we have to insert this value in between the two values. Okay, that is called as framing. Okay, and there are 2 types. First is character oriented framing. If you put a character in between, that is called as character oriented framing, and if you put a bit in between, that is called as bit oriented framing. Okay, so this is the flag. If this pattern is coming, that means this data has ended and new data will begin from here. Okay, so that is the flagging. And sometimes what happens is this same flag will come inside this only, so it will mistakenly think that the data has ended here after this flag has encountered in the same part here. To avoid that, extra 0 will be added so that stuffing will happen. Okay, so that will ensure that this is not taken for a flag here inside the data part. Okay, then we have the flow and error control. What is flow and error control? Flow is the control of balance between the production and consumption. Okay, so the number of bits is being produced by the producer, that should be equivalent to how much it is getting consumed at the receiver side. Otherwise what will happen, there will be overflow at the consumer side, right? So when there will be overflow, there will be bits going wasted, and the data received will not be full, right? It will be having a missing values. So to avoid that, we'll be using a flow control. How does flow control work? this is the sender side, this is the receiver side. The frames are being pushed here in the receiver side. They'll be receiving the frames and giving a feedback if it is having a flow overflow, so it will stop sending or make the sending slower. Okay. So also error control uses CRC, cyclic redundancy check, which we just discussed above. And there are two types of it: connectionless and connection oriented. In connectionless protocol, the frames are not numbered or ordered. Okay, like all the frames are random and they are sent together. It is faster and there is no checks also happening. This is not secure, also not secure. Okay. So this is the connectionless oriented protocol. This connection oriented will have the three phases: setup phase, which will do the numbering and the ordering of the frames, transfer the data, and tear down phase will just means break down the connection, and it will have a secure connection as well here. But it is a bit slower because these steps are being happened to make it more secure. Okay. And what are the data link layer protocols? There are two protocols: simple and stop and wait. Okay. What is simple protocol? We'll always represent the protocols using finite state machines. Okay. What is simple protocol? It's nothing much. It's very basic. Here is the sending part, here is the receiving part. It will just keep on sending the frames, that's all. Okay, there will be no checks, there will be no wait for the acknowledgement, and there will be no collision detection. If any other frame has get lost or corrupted, nothing will be there. It's just sending the frames. Okay, so the FSM will also be very simple for the sender side, for the receiver side. In the sender side, the start button, it will be ready and it can send it, and the receiver side, if it is ready to receive, it will receive the frames. Okay, flow diagram will be as follows: the packets are here and it is sent, and the first packet and the last packet is received here at the time corresponding times. Okay. And the second one is stop and wait protocol. It uses both flow and error control. Okay, so the stop and wait protocol will work as follows: the sending node will send a frame here, and once the frame is received here, it will send an acknowledgement, and the acknowledgement will be received here. Until an acknowledgement is received here, it will not allow any other frames to come. Okay, so that is called as stop and wait protocol. The FSM diagram will be as follows: ready, and it will go here, and it will be blocked until it reaches gains an acknowledgement. If it does not gain acknowledgement, again it will come back here and resend the frame. If it receives the acknowledgement, it will send the next frame from here. And the corrupted frame, if it is arrived, it will discard it. If it is not corrupted, it will send an acknowledgement. Okay, so flow diagram will be as follows: here the frame is there, it sent the frame, it received here, it sent the acknowledgement, received here. Next frame is sent. If it's lost, again it will be resent after some time, and it is received here, and the next frame will be sent. Acknowledgement is lost, that means it does not know that it means, see, the sender side will not know if acknowledgement is lost or the frame itself is lost, because both scenarios they don't get acknowledgement back. So in that case, it will resend the frame. If it's duplicate, it will ignore it and send an acknowledgement back. If it's not duplicate, it will take the frame here. Okay, we have next topic, which is HDLC, high level data link control. It implements both flow and error control. Okay, high level data link control also the same thing whatever I discussed in the top, just at a more better level it will be happening. Okay, it has more protocols and secure. It has two modes: normal response mode and asynchronous balance mode. So normal response mode will have a command send and then the response will be taken. It is unidirectional. If it is point to point, multi-point means multiple responses will be taken from a single command. Okay, and if it is asynchronous balance mode, the command response will happen at the same time bidirectionally. Okay, and HDLC frames are there. What are the frames? Along with the actual data, this is the actual data, this is the actual data, actual data. Along with that, some other data also gets transferred. So let's have a look at what type of data gets transferred. Firstly, there are three types of frames: I frame, U frame, and S frame. I frame is used for transferring user data, which is the normal data, and S frame is used for transferring the flow and error control data, and U frame is used for transferring session and management information data. So here we have the flags to denote starting and ending of the frame, address of the destination part, and here is the control part. We'll discuss in depth about this one in a few times. FCS is the frame check sequence. Okay, so in control part we have the following. So observe carefully, we have different control frame field for I frame, S frame, and U frame. So what is I frame having? It has the 0, 1 0 and 1 1 present here. What does this denote? 0 denotes I frame, 1 0 denotes S frame, 1 1 denotes U frame, to denote which type of frame it is. Secondly, NS means the sequence number, and NR means the acknowledgement number. Those will be stored here. And P or F means, P means pole, F means final. Pole means any intermediary transaction happening. Final means final transaction happening to denote that if it is a intermediary packet or the final packet. And the code part is here. So code part can be divided into further parts, which can be like type of S frame or U frame. There are different types of S and U frames, so that will be specified which type it is. Okay. Next we have point to point protocol. Point to point protocol does not provide flow control, but it provides error control and using SRC. If the frame is corrupted, it is discarded, else it is taken. The second one is the frame format. In PVP, the frame format will be as follows. It will have a flag here, address here, which it is discussed, control packet will be there, and protocol will be there, means type of data will be specified. Payload will have the actual data. FCS is the frame check sequence to check which sequence of frame is, and flag will denote the starting and ending of the data. Okay, and the transition phase is as follows. In the PVP, we will be having the dead state in the first, and we'll be having a carrier detected, and connection will be established. Authentication will happen, and if it is successful, it will pass to the network layer, and then it will do the transfer of the data and terminate it. Okay. The third topic among the three topics, the last topic is the MAC, which is the media access control. As you can understand from the term, we are controlling the access to the media. Okay, so why we do that? It's because there are multiple nodes which are competing for single link of data. Which node has to send the data? To manage that, we'll be using MAC, which is media access control protocols. So it is divided into three categories: random access protocol, control access, and channelization protocol. In this module, we'll discuss the first two only. Okay, let's have a look at random access protocols. It is having four categories: ALOHA, CSMA, CSMA CD, and CSMA CA. Okay, so random access means each station does not have a priority on the other station. All the stations are equal. So which station has to send data, that who will decide? That will be decided by our random access. Okay, that means that it can send whenever the means it can always send the data. Okay, all the stations can always send the data, and if two or more stations send the data at the same time, there will be collision and both will be lost. Okay, so it is a very useless protocol, but it was the first protocol built. Okay, that's why there are many disadvantages. So here, see, four stations are there, and gray area, as you can see here, this means that the packets were at the same time sent, so there is a collision, all of these are lost, and here also these two are lost. So out of 8 packets totally sent by each by all the stations, 8 packets were sent, only 2 were taken into consideration. The 2 packets were correct, other all were discarded due to collision. Okay, so the procedure will be as follows: send the frame and wait for some time, and if acknowledgement is received, it's fine. If it's not, again wait for some time and resend the message. Okay, this is the procedure of ALOHA. There is another type of ALOHA, which is the slotted ALOHA. Here it will be having a different slots present. So this is slot, and this is slot. So the packet can be sent only during the slot, starting part of the slot. If it misses, it has to wait for the next slot. So what happens? Collision will be reduced, because there will be a lesser chance of sending the data at all these points. It will not send data, and if it's means whatever the that packet has come, that will be transferred to the end. But collision can still happen, but it is lesser. Okay, so here out of 8, 4 are having the collisions. It's better than the previous one where 6 were having the collisions, right? So this is slotted ALOHA. Okay, another type is the CSMA. CSMA means carrier sends multiple access. So link is present here. First, this algorithm will see if the link is empty or not, then only it will send. Okay, so it is doing a check on the link, which is a carrier. Okay, it will sense the carrier and then only it will send. Okay, but still the collision can happen because of propagation delay. Why? Because see, if the link is empty, the two stations are here, they are seeing the link is empty, so they will start sending at the same time, and after the words again they'll do the collision, because after the means if they want to send the, it will not happen instantly. See, if A wants to send the data to the link, it will not happen instantly, it will take 3 seconds or something. Okay, so during the 3 seconds, B will see and think that it is empty, and B will send at the same time. So after A has sent, after 3 seconds it will be visible, and B's packet will also come, and the collision will happen. So in graphically, it represents as follows: the gray area. This is called as the collision area. Okay. So the vulnerable time means when it can happen. It can happen when the T1 starts and reaches the destination. Till that point, anytime if any other station send the data, the collision can happen. Okay, that is called as vulnerable time. Okay, so what should a station do if the channel is busy? Suppose that the algorithm check channel is busy. What should it do? It should continuously check. That is called as one persistent. It should wait for some time and check. It is called non-persistent. It should means wait for some time and randomly check again and wait for backup time and so on. That is called as p persistent. Okay, Then we have the third one, which is CSMA CD. CSMA with collision detection. It will detect if the collision has happened or not. Okay, how it happens? It will monitor the medium. Okay, it will always see in the medium if the collision has happened or not. In the previous two, we will not know if the collision has happened. Okay, so here what will happen? If there is a collision happened, means A has sent the data, and C does not know A has sent the data, and C will also send the data, and at some point both will collide. When it collides, C will get to know the collision, so that what will happen, it will take back the data, and A will get to know the collision after the eventual time, and it will take back the data. So this is the CSMA CD. Okay, CSMA CA, collision avoidance. How is the collision avoided? There are three strategies: interframe space, contention window, and acknowledgement. Interframe space means it will be having delay in between sending the data, so that the channel will be able to send the data when it is empty. Okay, contention window is the amount of time divided into slots, and these slots will be there, and in these slots only it can be send the data. Acknowledgement is ensures that the data is received by the receiver. So acknowledgement also gives a surety that we'll be getting the data or not getting the data. At the end, we'll be getting to know that. Okay, and the second one, the first one was random access protocols, right? So four were there, and this is the control access protocols. Here we'll be having three types: reservation, polling, and token passing. Very simple. Reservation means the stations will be reserving some slots where they can send the data, so that no other station will be sending the data at the same time. So reservation is the one. Polling means all the stations will be competing, and the primary station will be deciding which to give the priority. Okay, that is called as polling. Token passing means we'll be passing the tokens. Okay, so this is the reservation. The reservations has been made here, and polling means selection will be happened by the primary. So primary will be deciding whom to give access, A or B, and the token passing means the token will be passed to one after the other. They will be lined up in the form of a ring. Okay, at first you will be doing the data pass, then I, then this, and so on. It will be continuous. Okay, so this is called as token passing. There will be a token, and whosoever has the token, they will be able to pass the data, and token will be passed sequentially to the next person. Okay, there will be a predecessor and a successor here. Okay, so if it is in the form of this one, unidirectional physical ring. Dual ring means it will be bidirectional. If it is a bus ring, means there will be a bus, and they will be having a connection for passing the token. First this, then this, then this, then this, like that. And the dual ring will be having like this ones. Hub will be there in between. Sorry, this is the star ring. A hub will be there, which will be passing the uh, token to the respective stations. Okay. So that's all for this video, and make sure you hit the like button, subscribe to my channel for more videos like this. Thank you so much for watching. I'll see you in the next one.